devolved.
They took stuff that would have been useful as by itself,
Right.
took away value.
What is the little toy kitchen thing could be useful for daycare maybe?
Sure.
That thing was huge. Like, I wouldn't haul that into my house.
Hey, since we're talking about it, I want to shoot this thing out here to you. This is one of the three pictures Tim sent me for our solar thermal. So this is chapter 2, technology in action. What do you think that thing? Would that cost you? Maybe in
From that place?
yeah, like
I think we figured about $30.
$30, yeah.
$30. I'm just
That's what
gonna
the cost of the windows.
do a little bit of math here.
$30?
Yeah. Now, what would you insulate that with?
Probably that concrete board seemed to work really well, or cement board or whatever they call it. It's like drywall, but it's concrete with fiberglass meshed in.
So $30, and then there are 4 of you, 5 of you,
4 of us,
4. How many person hours?
6 each, so 24 hours.
24. So I'll just call that $500 worth of labor.
All right.
That's pretty skimpy, but $20 an hour, for
Some seriously
fabrication.
skilled labor.
Yeah. $500 an hour. I mean, we can even take that up, but you're well under $1 a watt for your technology, right? I mean,
Oh, yeah,
you're
about
so
30 cents a watt.
yeah. So, well, shoot, let's just call it. Well, do it all the way here. 530 divided by 1600 equals. Got a calculator going here somewhere. Maybe not. 530. Yeah, 30 cents a watt. It's pretty good. Beats the $10 per watt, 3 megawatt PV array that we're trying to put in. But man, that thing, that's starting to really heat up because unfortunately, well, this is in line with what we're going to talk about today with bioenergy, but the university got so burned on that whole biomass boiler plant that now there's a chance to put in a giant photovoltaic array, but just the initial analysis, somebody, no one's just going to say, hey, we'll quote you a cost without doing anything up front. So there's a retainer fee of several $100,000 that the university is now considering, and the fear is that if you don't pay the retainer fee, the project doesn't go forward. And they're afraid of losing the retainer fee and the project not happening at all. But
So some craziness is maybe you could go to the program that actually teaches that stuff and say, hey, how about if we make that a project? Or make it a project for a grad student.
yeah, it's a great point. The problem there is, we had a similar problem paying, what's his name, Connor Darby to teach PV because his company was a preferred vendor for the university, and so it was considered conflict of interest to have him teaching and, doing engineering for the university. In the same way it would be for me to sit down and do that too. I don't know. Yeah, I'm not sure how much.
But at the same time, we could give them a proposal, we could give them numbers, and then they can go to them with some preloaded with knowledge.
Yeah.
of
Well,
whether or not it's feasible for their.
yeah, Brian Kearns has actually done all that. I mean, his full-time role at the university is energy efficiency expert, and he's done as much as he can on behalf of the university. But anyway, I hope it goes forward. Okay, so let's get into 102. And just catch everybody up on the syllabus. There was one little question about formatting equations and summaries, and if I remember correctly, we did do a fair amount. You guys allowed me to blab on a little bit about the dimensions of entropy in that paper, so thanks for letting me do so. But I am going to get back in and just show you one or two other things about the summary before we move on. So, Learning Unit 1, we finished last week. There will be an exam launched shortly on the first 3 chapters, first 4 weeks. And now we're getting into Learning Unit 2. We basically have 2 weeks to cover biomass, so I'll get as far into it as I can today and Thursday, and then Tim, I think you and Mark are going to tag team on this next week, so I'll just have you pick up wherever I leave off on Thursday, and then Mark's going to do. He's a pretty good biomass guy. I haven't worked the mill, so he's got a few things there, but I'll give you a chance to play with this stuff a little bit. I just want to make sure you've got what you need on this computer. Okay, so
Still some problems from Brian Kerner's class.
Oh, perfect. Yeah.
Is that 242, 243, something?
Yeah, 241 and 242. Yeah. Yeah. Okay, so scrolling down here, exam 1, chapter 1 and 3. So I could even launch this exam now. I think we're ready for it. But let's just have you plan on finishing exam 1 by this time next week.
Okay.
On chapters 1 through 3. So it's sitting right down there. We'll launch it, get it going. And also, I do want to show you a couple little tricks in Microsoft Word for editing equations. So let me just start with a fresh one here. And show you how I deal with these things. For example, Newton's second law states F equals, always put a space in between your symbols and your operators, so F space equals MA. If you're not sure, hit Control-Shift-8. Control-Shift-8 will bring up your meta characters. Also, I tend to like to see, especially mathematics, written in Times New Roman, which has, and the Times New Roman font has serifs. Serifs are these little legs, these little things you might imagine writing if you're using a calligraphy pen. And typically the sans serif fonts are for tables. And the next thing I'm going to do is put in a couple tabs. So there's one tab right there. And I'll do Control-Shift-8 again, and I can hang on, time out. Oh, that's funny. The tab that I just hit actually turned it into an indent. I do not know why. Two separate things. Tab. Tab. Weird. That is bizarre. Okay, so something new happens every time you start Microsoft Word, and tabs are now turning into indents. Good. Glad for that. Let me do this then. Tab. And there's a couple different styles of tab that are handy, and this will save you from putting in a bunch of spaces and all that kind of stuff. So one is the center tab. I'm going to do that right here. And now I'm going to actually try to put in, okay. That time it liked it. for whatever reason, the tab that I put at the beginning of the line was actually treated as such. I'm going to remove that indent, because it's not doing anything for me. The other type of tab I want to show you is the right tab. So now you can see that my cursor did that. So I've got my equation in the center, I've got my right tab ready to go for my equation number. Now, I'll do an open paren. This is not going to be as important for your 102 summaries, but this is just the formal way to do it that I've found is the best. So, and then I'll go up to insert, and then there's a thing called a field, which is in quick parts. And the field that I'm going to put in is a sequence field, SEQ. And you can name it whatever you want. I'm going to call it an SEQ, EQ for equation. That goes in there, and it just made the number 1. So now, anytime Microsoft Word sees that, it's going to just order these numerically, 1, 2, 3, down the line, etc. I'll close the paren. I'll type a return. States that F equals MA, where F is force, M is mass, and A is acceleration. So another thing to fix here, that sentence, or that equation is part of the sentence. So you would just read it out loud. For example, Newton's law states that F equals MA, comma, is one convention. You don't have to do that. Some conventions insist that you actually punctuate your equations like that. You can take it or leave it. But the point is, the word where is part of the sentence. It is not a new sentence, so it does not get capitalized. Where F is force, italics, since it's a variable, M is mass, and A is acceleration. It's also important that you keep in mind that these variables are case sensitive and that they all get italicized. And it's especially important that you italicize the letter A there for acceleration so that it's clear that it's not the word A, that it's the letter A. So I've got the equation centered, I've got it numbered. You can come down here. We saw that in, I can also come back in here. This is probably maybe a little bit of TMI, but very handy if you're writing longer documents. I would come in here and insert a bookmark and just call it Newton's second. Something like that. And then here I can come down and insert a cross-reference to a bookmark. There's only one there. Dink, close. So if I had a big, long, complicated document, I came back later, inserted a new equation, the numbers would update as would this thing. And the same thing works if you use references, insert a caption. So it'll stick a figure 1 in there for you, right? And if I take this guy, copy it, paste it, it'll automatically number those two. So the sequential fields and the one that I just made for the equation and the caption fields automatically update.
Show them how to do symbols.
Oh yeah, for sure.
Stuff, or
Okay, yeah,
not in this particular formula, but
Yeah.
the formula has that.
the power of our solar thermal technology we use. P equals FA. So I can just take this guy. In fact, I'll just do it this way. I'll copy this whole line. I'll come down here, paste that. I've got the font that I need already. So here goes P for power. And then I'm going to go FA on that. And so up here in the home screen, I've got the symbol F highlighted. If I type symbol under my font type, it turns that F into a phi. And so you could use that for mu for micro. You can take your H and turn it into an eta for efficiency. You can take a Q and turn it into theta for degrees angle. And then, through the magic of the fields, if I get my cursor just so, update that field, that's number 2. I didn't type that, it just keeps track of it for me, and I could put a bookmark in it. Okay. I'll save that. I'll put it into NRGY 102. So that'll help you in the rest of your summaries. And typically you only have, one equation, maybe a couple. So some of the numbering's a little bit overkill, but still nice to keep it tidy. Okay, so any questions on that at all? Summary 1 going well? A little formatting? Take a pause, come right back.